Hello, my beloved students. This is Ms. Riwan Hussein from the Science Staff, Middle Department EGC. Hope you are doing well. For today, we are going to cover Lesson 2 in Unit 1 for Middle 1 students. This lesson is under the title of Matter Construction. Actually, from the title, you will see that the lesson is talking about the construction of matter. So let me start first with matter. We have studied in lesson 1 that matter is anything that has mass and occupies a space, as a table, a window, water, even the air we breathe. Also, we have studied in lower classes that matter exists in 3 states: solid, liquid, and gases. Moving to the word construction, it means the building unit or the structure of a substance. So, in this lesson, we are going to study the structure of matter. Have you ever asked yourself, how can we build a city? When building a city, we start with bricks. Many bricks joined together make a wall. Walls working together make a building, and many buildings complete the city. Or do you remember what is the building unit of the living organisms? The human body is put together in a similar way. Humans start with cells. Many cells joined together make tissue. Tissue working together make an organ, and many organs make a system. So what about matter? What is the building unit of the matter? Let's perform an activity to show the construction of matter. Take some incense sticks and smell them. Place them in any corner of the room. Light the incense sticks. Try to smell them from a distance. What do you observe? The smell of the incense sticks spread all over the room and reaches our nose. This means that the incense sticks, which are considered as matter, are divided into tiny particles which cannot be seen by naked eyes or even by microscope. These particles spread all over the room, having the same properties of the incense sticks, which is its smell. These particles are known as molecules. So, we conclude that matter in any state, solid, liquid, or gas, is formed of very small units known as molecules. Similarly, if we spray perfume in our room, the smell of the perfume spreads all over the room. How does this happen? Perfume is a matter which is formed of small particles called molecules. So we can define molecule as the smallest particle of matter. And as we have said before, that these perfume molecules spread all over the room, so the molecule can exist freely. Also, we smell the same odor of the perfume, so we can say that the molecule keeps the properties of matter. So we can define molecule as the smallest particle of matter that can exist freely and keeps the properties of matter. We will explore the properties of molecules of matter by doing some exciting experiments so that you can get a visual feel of it. I'm sure by the end of the video the concepts are going to be super clear to you and you will find it easy to remember. Let's perform an activity to prove the first property of molecules. Fill a beaker with water. Add a drop of potassium permanganate solution to the water. What do you observe? The violet color of potassium permanganate spreads in the water. This means that the potassium permanganate dissociates or breaks into particles that spread among the water molecules. This proves that molecules of potassium permanganate are in continuous motion. Now, let's visualize this scenario. So, imagine we zoom into this glass of water a million times. So how is it going to look? It probably looks something like this. The white balls here represent the water molecules, and when we add a drop of potassium permanganate into water, it breaks up into tiny particles like this represented by the red balls. And since the particles are constantly moving, they spread across the water molecules. This proves the first property of molecule, which is molecules of matter are in continuous motion. So, as we said before, that matter in any state, solid, liquid, and gas, are in continuous motion. As you can see in the picture, motion of solid molecules is limited, or it seems as vibratory motion. Motion of liquid molecules is free. Motion of gaseous molecule is completely free. Now, let's take a look at the second property of molecules by performing this activity. Measure 25 cubic centimeter of water by a graduated cylinder. And put the water in a cup. Measure 25 cubic centimeter of alcohol by a graduated cylinder. And put the alcohol in the same cup of the water. Mix water and alcohol together and measure their volume by a graduated cylinder. What do you observe? The volume of water and alcohol is less than 50 cubic centimeter, or the sum of them before mixing. This means that some of alcohol molecules are distributed in the spaces between water molecules. This proves that there are intermolecular spaces between the water molecules. Once again, we can visualize the addition of alcohol in water by using our bowl of water molecules that is represented by white balls. So, when we add alcohol to water, the alcohol breaks into tiny particles represented by the red balls that occupy the spaces between the water molecules. This proves the second property of molecules, which is there are intermolecular spaces between molecules of matter. So, the intermolecular spaces are the spaces found between molecules of matter, either solid, liquid, or gases. As you can see in the picture, spaces between the solid molecules are tiny. Spaces between the liquid molecules are large. Spaces between the gaseous molecules are very large. Now, let's move on to the third property of molecules. Can you break a piece of iron with your fingers? Or even by hammering? Definitely no, as the attraction force among the solid molecules are very strong, and that's why we cannot break it. But can you divide an amount of water in small cups? Yes, as the attraction force among the liquid molecules are weak. So, this proves the third property of molecules, which is there are intermolecular forces between the molecules of matter. So, the intermolecular forces are the forces that bind the matter molecules together. As you can see in the picture, forces between the solid molecules are very strong. Forces between the liquid molecules are weak. Forces between the gaseous molecules are very weak. Are you ready to explore the three states of matter with me? I'm sure you are familiar with the three states of matter: solid, liquid, and gas. When we look at something, our brain automatically knows, is it a solid, a liquid, or a gas? We are going to compare these three states of matter in a more scientific way, based on the properties of molecule we have discussed before, as the factor that decides whether the state of matter is solid, liquid, or gas is the arrangement of molecules in the different states of matter. Let me start with solids, as ice. As you can see in the picture, the motion of the solid molecules is limited or vibratory motion. And this is because the intermolecular spaces between the solid molecules are tiny. The intermolecular forces between the solid molecules are very strong. So, this arrangement of molecules in a solid substance gives solids a definite shape and a definite volume. So, solid matter keeps its shape and volume whatever the shape of the container change. Coming to liquids, as water, as you can see in the picture, the motion of the liquid molecules is free, and this is because the intermolecular spaces between the liquid molecules are large. The intermolecular forces between the liquid molecules are weak. So this arrangement of molecules in a liquid substance gives liquid indefinite shape and definite volume. I'm going to prove this point to you with an experiment, and you carefully take a look. What is the change in shape and volume of liquids? Collect different containers of various shape, like a beaker, a conical flask, and a cylindrical jar. Put the same amount of water in each container. What do you conclude? Liquids have definite volume and indefinite shape. So, liquid matter takes the shape of the container. Now, let's take a look at the third state of matter, which is gases, as water vapor. As you can see in the picture, the motion of gaseous molecules is completely free. And this is because the intermolecular spaces between gaseous molecules are very large. The intermolecular forces between the gaseous molecules are very weak. It almost not exists. So, this arrangement of molecules in a gaseous substance gives gases an indefinite shape and indefinite volume. As we have studied before, that there are three states of matter, which are solid, liquid, and gas. So, how can we change the state of matter? Let's say we want to go from solid state as ice to liquid state as water. Or we want to go from liquid state as water to gaseous state as water vapor. What is the way by which we can change the state of matter? Yes, by heating. We can say by changing the temperature. As you know from the previous lesson, to go from the solid state as ice to the liquid state as water, we need to heat it. This process is known as melting process. To go from liquid state as water to gaseous state as water vapor, also we need to heat it, and this process is known as vaporization process. Now let's talk about melting process by performing an activity to know the effect of temperature on the change of state. Put a beaker filled with ice on a burner. What you observe? Ice cubes change into liquid water by heating, and this process is known as melting process. So we can define melting as the change of matter from the solid state to the liquid state by heating. Now let's visualize the melting process based on the molecular structure by taking a closer look to what is happening here. When a solid substance is heated, its molecules gain thermal energy, increasing the speed of molecules. The intermolecular spaces between molecules increase. The intermolecular forces between molecules become weak, so the motion of molecules becomes free. So the solid substance changes into the liquid substance. Now let's talk about vaporization process by performing an activity to know the effect of temperature on the change of state. Put some water in a beaker. Place the beaker containing water on a burner. What you observe? Water changes into water vapor by heating, and this process is known as vaporization process. So we can define vaporization process as the change of matter from liquid state to gaseous state by heating. Now let's visualize the vaporization process based on the molecular structure by taking a closer look to what is happening here. When a liquid substance is heated, its molecules gain thermal energy, increasing the speed of molecules. The intermolecular spaces between molecules increase. The intermolecular forces between molecules become very weak. The motion of molecule becomes completely free. So the liquid substance changes into gaseous substance.